Akira, developer relations at Bright Security. She's a technologist in the broadest sense of the term. She's a tech community, an enthusiastic tech educator, and the most recently a bridge builder between the tech world and traditional art forms. Her interests and experience span web development, community building, cybersecurity, introducing new technologies and ideas to software developers, and performing arts. She's also a professional opera singer, and in her free time, she's turning her house into a mini farm, growing vegetables and mushrooms. Akira, welcome.
Hi everyone. Welcome. Welcome to my talk. My name is Akira Brand. I work in developer relations at Bright Security, and this is my talk. Security is everybody's job. So let's get started. What are we going to talk about today? First off, this talk is about DevOps, and most importantly, it's actually about adding security to DevOps. So I'm curious, do you write code as part of your job? If you do, go ahead and raise your hand wherever you are right now. Yeah, that's me. I write code as part of my job. Do you do patching as part of your job? If so, raise your hand. That's me. I do patching. This is a question that probably everyone's hand is going to go up for if you are raising your hand. Who here goes to meetings as part of their job? I'll put both my hands up because I go to a lot of meetings. And then lastly, who here does security as part of their job? I do. It's actually almost my entire job. But maybe your hand for this one didn't go up. But what I'm hoping is that at the end of this talk, your hand will definitely go up on that question because I am here to convince you that security is part of everybody's job. So at the end of the day, the TLDR of this talk is we are going to try to convince you that security can indeed become part of your everyday work. Security is everybody's job. So here's how it stands now. This is often how security people see DevOps people, and sometimes it's how they see developers too. This is obviously not the greatest relationship on the planet, but what I will say is that the days are gone when breaches were rare and security could safely be put low on the priority list. Now, product security is a customer demand. Customers absolutely need to have secure products. And cybercrime, especially since the COVID-19 pandemic, has reached epic proportions. Our idolization of hackers, penetration testers, and breaking, unfortunately, has not resulted in secure software for our industry. Merely, it has only resulted in egos, stereotypes, and truly unaffordable security models. Modern application security approaches need to address both offensive, which means red team, and defensive, which means blue team approaches, as well as continuous learning and advocacy for developers. This means purple team. This talk will explore how to combine defense, offense, automation, empathy, and continuous learning, all without the requirement of ever wearing a hoodie. I truly believe that the future of security is purple. Let's talk a little bit about me too, so you know that I'm actually qualified to teach you this topic. So my name again is Akira Brand. I currently work in developer relations at Bright Security. I've been in tech formally since 2019, so not all that long, and I am newer to AppSec, so I want to call that out there. I'm learning a lot as I go along though, and one of my passions is to teach other people as I learn and what I'm learning. So hopefully today you're going to get a lot of information that is valuable to you, even though I myself am somewhat newer to this field. I'm a former musician. I worked as an opera singer for over 10 years. And last but not least, I am a tech educator and always being constantly educated. I actually just started my degree in computer science, so I'm very excited to be here and teach you all kinds of things that I'm learning along the way. So, on that note, let's do this. So, what is application security? What are we even trying to weave into a DevOps environment and a developer's workflow? If we don't know what it is, then of course, how can we possibly do that? So application security is any and every activity that you perform to ensure that your software is secure. So what does that mean? Well, that can mean threat modeling. It can mean doing secure code review. It can mean doing oh gosh, let's see here. You can put a software composition analysis tool on your code. You can point a DAS tool like Brights at your code and see if you can do automated pen testing on it. Any and all activities that you perform to ensure your software is secure constitutes application security. Now, what I'll say is poor AppSec is a problem. And when I say poor, I don't necessarily mean badly implemented or like poorly done. It's just that a lot of places don't even do it in the first place, and that's what I consider poor AppSec. So yes, improperly implemented AppSec or completely vacant AppSec or AppSec that isn't there in the first place causes about 29 to 40% of breaches according to the Verizon Data Breach Report up to 2020. However, as of the most recent one in 2022, poor AppSec can actually cause up to 60% of breaches, which is a big deal. You can also see here a graph here if you want to take a look at that in a little bit more detail. And what I will say is that if it's causing up to 40% of breaches, maybe you would think that you are spending 40% of your security budget on application security. However, that is rarely the case. Trust me, you're not spending that much money on application security. Also, application security is a problem because it's missing from traditional education. So AppSec is not covered in most post-secondary computer science and software engineering programs. And when it is, it's often an afterthought. I have taught collegiate level computer science courses. I have helped actually write curriculum for collegiate level computer science courses, and I'm currently working on a degree right now for this as well. So what I will say though is that through my entire experience in academia, cybersecurity has maybe been an afterthought at best. We would have potentially one module that we would go over cybersecurity issues, but even then it wouldn't be necessarily AppSec. It would be something that was very esoteric and strange, like how handshake protocols work and TCP and things like that. So AppSec is definitely missing from all of our premier education. Even in the best schools, we just really don't talk about it. So that's a problem. A lot of developers then are going into the field. They know how to code, and some of them might be coding wizards, and you know, there's all kinds of gradients of skill. But if you don't even know application security exists, no matter how good of a coder you are, you're going to have security vulnerabilities that you introduce into your code. Now, talking about in the professional world, security is also outnumbered. For every 100 dev persons, there's probably maybe 10 ops people and 1 security engineer. So that's if we're lucky. And this is in a traditional waterfall environment. So imagine that you are having security issues being shipped into production that the ops team is finding, but even then there's not enough ops people to really remediate it. And then you have this one poor security person that's just having all these issues dumped and dumped and dumped and dumped. If you can imagine the issues sort of like water being poured into a cup. In this case, it's like someone is pouring water into a cup and the cup is overflowing, and then the person continues to pour water for another 2 years, trying to undo the damage it's done. So it's not working very well at all. So what I'll say, going back to that, is that the original model of waterfall, the original model for building software, which was called waterfall, and then we have agile, and now we have DevOps, it never worked well for security. If there was a security issue, the whole process would stop. And you'd have to loop around sometimes months or even years after the initial problem. So it's kind of like if you've ever played a game called Monopoly, there's a chance card you get. You have to pull a card and it'll send you right to jail. You don't get to collect your paycheck, you don't get to do anything. You just go right to jail. And that's kind of how it felt like, is developers would have security issues and they would need to release this software, and the security team would find something wrong. And they'd say, nope, you can't do that. You need to stop. You need to like quit everything you're doing, start from the beginning and redo it. And that just does not work, especially now in a modern DevOps environment. So what is the solution? Well, the solution can be something that we like to call DevSecOps. So this is DevOps with security right there in the middle. So like we talked about, the security is everybody's job, and that DevSecOps is just application security inside of a DevOps environment. That's what we call it, DevSecOps. So this is kind of what I like to envision that security and DevOps and devs all look like together when they are practicing this concept called DevSecOps. So what is DevSecOps? What am I even talking about? Like we said, it's AppSec, but in a DevOps environment. So how do we integrate DevOps and security? First off, there are 3 ways of DevOps that we need to fully understand before we can start integrating security into each one of those 3 ways. The first way is to emphasize the efficiency of the entire system. The second way is to provide fast, continuous feedback. And the third way of DevOps is continuous learning and improvement. Now, when I say way, I'm not saying that these are hard and fast rules. These are kind of more like the Tao, or like the way. Like it's a way of practicing DevOps that all DevOps professionals are mandated to do it in this manner. So those are the 3 ways of DevOps. Now, let's talk about the 3 ways of security. So in security, we have something called a CIA triad. This stands for confidentiality, integrity, and availability. Now, when I show this to my developer friends, most of them have no idea what this is. We definitely need to change this. Everyone should know what this is. But what is it? It's the mandate for all security teams to make sure that applications are confidential, that they are integritous, and they are constantly available. Let me tell you a story really briefly about why this matters in a software sense. So let's say, for example, there are 2 people. Their names are Alice and Bob. And I'm taking this from a really good book called Alice and Bob Learn Application Security by Tanya Jenka. This is not my original story, but throwing a little twist on it. So anyway, Alice is a very high-powered businesswoman. She is a CEO at a very large Fortune 500 company and has a lot of influence. She has a lot of power. She also has type 2 diabetes. So what that means is that she has to take her blood sugar levels multiple times throughout the day to make sure she stays healthy. Now, in the CIA triad, you would think maybe that availability would be the most important thing for her software that her reader uses. But in this case, if there's maybe a missing reading once in a while, it's not that big of a deal. But what really matters to Alice is that this information is kept confidential. And the reason is that she is concerned that if someone finds out that she has type 2 diabetes, they could use that almost as like a weakness against her and maybe use it to sort of say, oh, like Alice isn't as powerful as she thought she was, like you can't really rely on her because she's chronically ill, things like that. So it's very important to Alice that her data is kept confidential, and that's part of the CIA triad. Now, let's talk about Bob. Bob is a government worker. He's been working in the post office for, gosh, let's say 35 years, a very long time. He's an older man now, and he has a heart rate monitor that he has to make sure is always up to date, and he's doing what his doctor says. He's decided he's going to start the Mediterranean diet. He's going to have some red wine, whole grains, fish, take care of his body because he wants to be around for his grandkids. Now, Bob doesn't care so much if people know that he has a heart condition. It's really not a big deal to him. It's not going to impact his professional life if people know that the same way that it would impact Alice's. But if Bob's heart monitor, if the software that runs it goes out for even a second, that's a huge problem with the availability section of this triad because Bob could die. That is the most severe consequence for an individual, is this cease life, is to not be able to live anymore. So the availability section of this CIA triad is incredibly important to security professionals and has real world implications. The last thing I'll say about this triad is the integrity piece. The integrity piece essentially means that the data in a software application or a software application itself is not corrupted. So, for example, if there's a hacker that is able to social engineer his way into a bank, so social engineering essentially means tricking somebody into giving you credentials that you shouldn't have. Let's say a banker has somehow given a hacker their credentials, and the hacker goes in and they don't necessarily steal money, they just cause chaos. They're just there to mess with the data and screw it all up and make sure that it's all flip-flopped and flamboozled, and it's just, most times hackers would just steal the money and be done with it, but this hacker for some reason is just very chaotic. So this affects the integrity of the application. It affects the integrity of the application's data. So now there's just mayhem and bedlam everywhere. People cannot get to their bank accounts. They can't access their money. Maybe it says that, you know, they had $1,000 the day before in their account, and now they have like negative 45 just because the hacker messed with the numbers. That also, as you can see, is incredibly important to people. Maybe not as serious of a outcome as end of life, but if you have, you know, if you lose a bunch of money randomly one day, that's pretty serious. Also, integrity has a big section for companies having a good reputation. So if the integrity of an application or an application's data is compromised, that's a big problem for companies, because now they have to pay lawsuits, they have to pay fines. In the public's eye, they look really terrible, and they lose a lot of trust, and like rightfully so, right? If someone gets your company's data, especially if you're being careless and that's how, then yeah, like the public should maybe think twice. But regardless, integrity is a big deal, especially for corporate interests. So let's go back to DevOps. We've gone really, really deep into the 3 ways of security. Now we're going to go really deep into the 3 ways of DevOps. So again, the 3 ways are: emphasize the efficiency of the entire system, not just one part or your part. The second part of DevOps, or the second way of DevOps, is fast feedback loops. So getting those loops of feedback to be quick, not 6 months later, not a year later, however long it would take. The third way of DevOps is continuous learning, risk-taking, and experimentation, i.e. failing fast, and spending time to improve your daily work. So let's talk about the first way of DevOps. Number 1, emphasize the efficiency of the entire system. So this is the system development lifecycle, sometimes also called the software development lifecycle. And in each one of these sections is a different segment of how someone designs, builds, tests, and release software. In DevOps, we don't just want to take a look at the entire system and try to make it all efficient all at once. No, we want to take each individual little section and make it as efficient as possible. So for example, in this first section, which would be requirements, you want to maybe iterate quickly over the requirements. You want to get customer feedback very fast. You want to get the stakeholders to buy in, give them a draft, have them buy in, or say, no, we don't like that, and go over this in small sections very, very quickly, so that a lot of this can be done, so that you know when you move from the requirements phase into the design phase, you're actually building the thing that is actually required, right? So if you've ever done software development, this comes through a lot in feature development. If you've ever built an application from the ground up, this has a lot to do with like doing customer interviews, trying to figure out what the market needs at that particular time. And there's lots of different people that are involved with this. So again, the more you can iterate and do small chunks at a time, the faster you will go. The next section is the design section. Okay, fine. So here is where we're designing the application. Maybe you're designing the databases. And we need, again, to do it in small segments so that it is efficient. We don't just take design and go, okay, make it, design it. No, you're not going to design an entire web application all at once. You're having microservices. You're going to design one piece of those. Maybe you have a front-end huge website you need to build. You're not going to just design the whole thing. You're going to design the home page, you know? So making that as quick as possible. And then, of course, my favorite part, which is the code phase, the build phase. I've never worked anywhere that says, hey, build this entire web application. You have 2 weeks. That's insane. You have to do it feature by feature, piece by piece, little tiny segment by little tiny segment. Then next up, you have testing. So again, you're not going to just test the entire application every single time you need to run a test. That takes too long. You need to maybe test the lambdas, test the deltas of whatever it is that the person was building, that your dev team gave you as a QA person. It needs to be fast. So a lot of this, again, is just taking small sections and doing them repeatedly over and over so that this can be as efficient as possible. And of course, last but not least, we go into release. So that's kind of the emphasizing the efficiency of the entire system from a DevOps perspective. But what does this mean for security? So it means that security cannot slow down or stop the entire pipeline, which we like to call pulling the Anden cord, unless it's a true emergency. And security needs to learn how to sprint, just like ops and devs. It needs to focus on improving all of the value streams and how securing the final product and network offer value to all the other streams. If we do this right, then security issues can be fixed now. So again, DevOps main goals is improve deployment frequency. So you're going to take this one section of an app or a feature or whatever and shoot it all the way to the end to production as quickly as possible. Now this is good for security. Sometimes I feel like security people get a little nervous about how quickly it goes, but this is good because if a security bug is found, it can be fixed extremely quickly because you're emphasizing again the efficiency of the whole system is running little by little by little and just iterating. And so then if you find a security bug, well, you found it already way back in the design phase. It's fantastic. You can fix it now as opposed to, oh, I don't know, in 8 months from now when it's an emergency release and it takes a really long time. That might sound familiar to some of you. There's also a shortened lead time between fixes. So this means fixing all the bugs, including security bugs, much faster. So what does this mean for dev and ops? So there's going to be 4 photo slides plus the resource slide at the end, so get your phones ready if you want to take pictures. So first off, what does this mean for dev and ops? How can we actually do this? What is the nuts and bolts? How does this actually look in practice? So first off, the dev and ops team can actually help the AppSec team tune things like static code analysis tools. Excuse me, so when you have an SCA tool, that's what it stands for, static code analysis. When you have an SCA tool, you're going to need to tune it a little bit. You can't just throw it on there and be like, okay, great, it's done. You're going to need to tune it for the specific quirks of your application, for your needs, for time purposes. Maybe you don't want to run the whole thing on the entire app every time. And if the dev and ops team can help the AppSec team with that, it's going to go a lot faster, which is really good. Also, the dev and ops team can do something really great to have security a little more woven into their section of the job by when they find a security bug, put it in the defect tracker that is already being used for where you would find bugs in a regular environment. So where the environment would be tracking the bugs, excuse me, I think there's a lot of noise going on in the room over, I apologize for that. But where there would be a lot of bugs to be tracked that are regular bugs, also put the security bugs in there. So it's all in the same place. That can actually really help the AppSec team. It could really help, of course, the devs to be able to fix the security vulnerabilities without having to go on a witch hunt to find out where they are, where they listed. Just put them all in the same place. Oh, and one thing I'll say, this is very tongue-in-cheek. I don't actually expect people to do this, but don't mark them as fixed when the AppSec team isn't looking, please. Thank you. All right, so what else does this mean for dev and ops? So what this means for dev and ops as well is that you can use something called a template and a code sample that are known secure. So essentially you can make your own secure code library. So anything that you've already done that has been tested and already had security testing performed on it, reuse it as much as you humanly can, because you don't need to go and write, we don't need to write the same code over and over and over. We already know that. That's why libraries exist. That's why modules exist. So if you have a library or a module that you're reusing all the time anyway, run some security testing on it and see if it comes out as more secure down the line, and you'll notice that you're going to have less security bugs, which is fantastic. Another thing you can do is use pre-scanned images that are up to date and fully patched. So it's the same kind of thing, like run your security testing on these images, fix them up, and then use them. And then last but not least, you can help the security team set up automated and regular scanning of images and containers. At the end of the day, only deploying up-to-date images and containers can also help a lot. It'll just help decrease your security bugs. And like you can see, this is not something the AppSec team does. This is Dev and Ops. So if Dev and Ops can start to adapt this mindset of, okay, I'm gonna use a container. Have I done security testing on it? Is it up to date? Is it maybe am I repurposing some code from an older library that is already known secure? This will actually help quite a bit to improve the security, improve the confidentiality, integrity, and availability of the entire application. All right, so what does this mean for developers? What does this first wave DevOps mean for the devs? So the first thing you can do as a developer is, again, helping the AppSec team to tune the tools. So this can be stuff like software composition analysis. It can be things like a DAST tool, so that's Bright, Zap, Burp, SonarQube. So helping the AppSec team tune those tools, because again, you can't just really throw a tool on a code base and be like, okay, I'm done. Like you have to do some tweaking on it. And the second thing you can do is, of course, address the issues that it finds. So when the security issues are found, it's really good to dedicate some time toward remediating those issues. Otherwise, you're kind of wasting your own time with tuning these tools that if you don't use the readouts, if you don't use the logs, if you don't use the error messages that it found, if you don't fix essentially the problems that it finds, then you're just wasting your time, and no one likes to do that. Another thing developers can do is, if the AppSec team creates a security pipeline for testing for you, definitely use it. So if the AppSec team has gone to the trouble to create a security pipeline, hey, we're going to put this tool in the CI/CD. You can put DAST tools in the CI/CD. I think you can put SCA tools in the CI/CD. Use the pipeline. Please don't just turn it off. And if there's issues with the pipeline, tell the AppSec team. Say, hey, this is adding 30 minutes to my build, and I can't tolerate that extra time. Like, it's got to be faster. It's got to be 10 minutes or less, or whatever it is, right? Sometimes AppSec teams will accidentally, I don't think they do this maliciously at all, that's not it, but sometimes they'll put tools into the pipeline that actually can delay releases by like up to a day, and that's not great. So you must tell your AppSec team as well if there's a problem. By all means, just let them know. It's their job. The last thing that developers can do is to ensure your libraries and other third-party components are secure. So making sure you're not using dependencies that are known to be insecure. You can use tools like the OWASP dependency check. You can use things like Retire.js, Black Duck, Sneak. And again, you can put these things in your pipeline as well. So always help the AppSec team help you at the end of the day. It's really going to help. It's going to help them, and it's going to help you. So I like how they say, for your sake, for their sake, and for yours. Okay, what else does this mean for developers? So this is a thing that I find to be actually a really good idea. Make sad path tests. So don't necessarily only do positive testing. So does this work as expected? If an error is encountered, okay, the test just fails. But you can do something called negative testing that ensures your application can gracefully handle invalid input or unexpected user behavior. So what does that mean, gracefully? So for example, you're not just going to have an error message that logs out every single detail. You want it to not give very much detail, things like this. You want to maybe roll back to an earlier version of the application that is stable. Things like this are actually really important for security as well. So that is the first way of DevOps, and that is a lot of information. So if you didn't get all that, that's totally fine. This is a recorded talk. You can go back and look at it later. So now let's go to the second way of DevOps. So the second way of DevOps is fast feedback. Now, we talked about, of course, going from left to right, starting in the requirements phase, going to design, going to code, etc., etc. But in the security world right now, there is a big phase called shifting or pushing left. So what this means is that you're going to be getting information back to the beginning of the loop almost much quicker than you were if you were waiting all the way to something like a release phase. So in the olden days, like we talked about, the security team would maybe not find anything until, oh gosh, probably QA, the testing phase. But in this mindset change, excuse me, there's some sirens going on outside, but in this mindset, what you're doing is you're actually going to be including security people from the very beginning. So when you're building requirements, have an AppSec person in the room. Heck, you can have the CISO in the room. I don't care. Have someone from the security in the room so that when you're building requirements for a feature or for a full application or whatever it is you're building, they can give you their insight and they can say, hey, you know what, that's actually not going to work. You're going to need to do it this way for it to be secure, truly. Same thing in design, have someone from the security team there. In code, have secure coding principles. Let your security team take secure coding courses so that they can actually be building, excuse me, not your security team, have your development team be taking secure coding courses so that as they're building this code, it's actually coming out secure. So this again is all called pushing left. So DevOps and the shift left principle, so this is fixing costs and quality and security issues rises significantly as the development cycle advances. So here we have stage 1, coding, stage 2, build, stage 3, QA and security, and stage 4, production. Okay, so if you find security issues all the way here on the left, that's why we call it shifting left. If you find it all the way on the left in the coding phase, okay, it's like $80 a defect. It's not cheap, it's not terrible. But if you wait until the build phase and you find defects, well, guess what? It takes more time, it takes more people power, and you have to now pay more money, so $240 a defect. Go into QA and security, it jumps up significantly, almost exponentially to $960 per defect to fix it. And then in production phase, we have $7,600 per defect. Now, what I will say, this is from the Ponemon Institute research. This is from 2020. So if you can do the math and update for inflation, this is actually extraordinarily expensive. We want to avoid that. So what does this mean for security? So fast feedback loops means pushing left in application security. The goal of security activities in DevSecOps must be to shorten and amplify feedback loops so security flaws, meaning design issues, and bugs, meaning code issues, are fixed as early as possible when it's faster, cheaper, and easier to do a better job. So again, faster feedback equals shifting left. Also, what this means for developers, like I talked on earlier, is tell the security team what you're concerned about. So these faster feedback loops of security-related events and activities really come down to just telling the security team what dev teams and what ops teams are concerned about so they can ensure they don't negatively affect those things. What I will say also is that the feedback can go the both ways. So that, of course, the security team needs to feel comfortable telling the development team, hey, we found this specific issue in your code base maybe 4 or 5 times now. Would you please be willing to go back and write a test, a security-focused test, so that we don't have cross-site scripting on this particular page anymore? And that's really great because then all of the teams involved gets to know the application so much better that way as well. And they can iteratively and quickly start to tune and tweak the code base itself and add tests and tools and things like that so that everything is more secure on an iterative basis. So what does this mean for ops? So first off, participating in security activities like secure code review, CI/CD pipelines, such as things of this nature. Having more proper incident response, being involved in incident response as opposed to just, oh, hands off, that's the security team now. But really having a hand in that incident response. And doing things like threat modeling, that would be another thing of like a security activity, security sprints. It's also really great to do, so that not just taking security at the very end, but saying, okay, how can we weave in secure either secure coding principles, maybe education, maybe tooling, putting things in a CI/CD, things like that. How can we make sure the security is sprinting along with everybody else? All right, and et cetera, et cetera. I was trying to think, is there anything else I'm going to say? But I was like, no, I think that's it for this slide. So that is the second way of DevOps. The third way of DevOps is this is full circle, right? So this is the continuous learning and improvement. So we're always trying to get better. We're always trying to improve. We're always trying to reach that next level and learn from our mistakes. So what does this mean for security? So for security teams, this is really important. I'm talking to you. Every moment possible should be a teaching moment. So you need to allocate time for the improvement of daily security work for dev and ops, and you need to enable both teams to get this done. Another great thing to do is to create rituals that reward the team for taking risks, especially security. Security is really scary. Like we talked about earlier, we never go over this in school if you're a developer, ever. So trying to code securely, trying to understand security, it's a huge field. It's really terrifying. Celebrate the successes. Celebrate taking risks. Celebrate someone trying, even if they fail. Heck, you could have a failure quota. Maybe, hey, I need you to fail 5 times this week, because if you're failing, it means you're trying, right? Another thing that's really fun to do is to introduce faults into the system to increase resilience. Like red team exercises and chaos engineering is a lot of fun. So you can also kind of try to catch people like, oh, did you see that thing that we introduced that was kind of wonky? You did? Good job. And then you go through your ritual to celebrate the success. So what does this mean for developers? Well, first off, accept the security training if it's offered. Hopefully your company will see the value in training you to become a more secure developer. If they do and they offer that training, take it by all means. Another thing you can do is train yourself. You probably didn't get trained on this in school. If you went to school, if you were a self-taught developer like I am, then you probably ran across it, but maybe didn't have a lot of great context. There just isn't a lot of great stuff out there for training developers on security right now. There's some, and we're trying to get better at that here at Bright by our initiatives. But train yourself if you can. If you can find the information. I'm going to leave you with some resources at the end too, like secure coding resources and some good books. Train yourself. Take that time and let your boss know, hey, I'm going to take an hour today and just teach myself some secure coding principles. I'm sure they'll love that. Or tell the AppSec team and they can tell your boss. The last thing I'll say for developers is pay it forward. Pay your knowledge forward. So when you fix a security issue, write it up in a GitHub gist and share it across the company. Or if you have a blog, write a blog about it. Or give a little talk, give a little presentation on it to your colleagues. First off, this makes you look freaking awesome. You'll look super smart. People will start to sort of come to you for some security issues, which is pretty good. That actually can differentiate you as a developer in your career quite a lot. But it's also just good karma, and it will help the rest of your team get a lot better. So what does this mean for ops? So for ops, there's a lot of stuff here. So this is going to be a lot of information. The first thing you can do is participate in security simulations. You can also ask for and analyze metrics from security testing results and look for patterns or systemic issues. So like we talked about earlier, maybe there's, I don't know, SQL injection going on over and over and over again, and your tools are saying, hey, SQL injection, SQL injection, SQL injection, and you find those patterns, then you can go back to the dev team and say, hey, we keep having these issues, maybe let's loop in the AppSec team and they can teach us about how to not have these issues anymore. But we need to fix this because our DAS tool keeps finding it in our pipeline. What's really important though is that when you do find those systemic issues is to perform a blameless introspection. So you don't necessarily want to go back and say, oh, like this is terrible, like Chad is not a good developer and Maria is even worse. Like you don't do that, right? And we all know this, like this is kind of like stage 1 of having a well-functioning healthy team is don't place the blame. But instead encourage and enable continuous experimentation, risk-taking, and learning from failure. So you want to push to improve security. You want to push for innovation and testing. You can't just be locked into one process. And understanding that repetition and practice is the prerequisite to mastery. So you have to enable this repetition. You have to enable this practice. Practice doesn't make perfect. Practice does make permanent. So make sure you are continuously learning that what you're practicing is actually accurate as well. So, like we said, continuous learning is the third way of DevOps. Now, security becoming a part of DevOps. What is it going to take? We now know what to do, right? We have all these great ideas, but how are we going to do it? How is this actually going to happen? Two words, which can be loved and hated and everything in between: culture change. This is one of my favorite topics, but it is very difficult. It is not easy to change a culture. It is not easy to bias a mindset towards security, especially if a mindset has been biased either away or neutrally towards in regards to security. So we got to reinforce the culture change over and over and over. Again, remember, practice does not make perfect. Practice makes permanent. So if we are celebrating security wins and we are adapting that practice, people are going to start to think, hey, if I fix a security issue, if I catch a security issue, or if I try something new and I tune my tool and I have 5 more problems come up and I remediate that and I get a party for me afterward, yeah, I'm going to do that. I'm going to continue to do that. You can also celebrate when things like you pass a pen test. So the whole team gets to go, maybe they go out for lunch and have a party and have a margarita. I don't know. But you pass a pen test. Maybe you made it through the security pipeline. Maybe you handled an incident really well. Maybe you released a security fix. Anything you do, like, party on, right? Party on, Wayne. Just celebrate that security win so that people can start to see that this is actually a really positive experience. Another thing that you can do is work more closely together literally. So if you're in the same office, if it's possible, put your offices next to each other. Have meetings together. Have social events together. Have lunch together. Get coffee together. Even if you're all virtual, you can organize like a brown bag security ops and dev lunch or something like that. So just getting to know each other a little bit better is also good for culture change. From now on, no more blaming. So when there's a problem, don't blame Alice, don't blame Bob, don't blame Chad, don't blame Maria. It's not that it's their problem or their error. It's that there weren't processes and safeguards in place to stop the problem from happening in the first place. We don't care about who. We only care that we're going to fix it and it's never going to happen again. This is called a blameless postmortem, and they are very, very powerful. It's okay to fail, but it's not okay to not learn from it when you do. Also, the last thing I'll say on that is that if someone needs to save face, allow them to, right? So it'll be more friendly in the future if you let people save face as opposed to just pointing fingers and scolding them publicly. Another thing I'll say is you can create security champions. So if a developer or an ops person is interested in security, if you're in AppSec, foster it. Or if you're in leadership, foster it. Send them to school for it, for God's sake. Like, send them a course, get them a book, give them work time to try new things, maybe make them a team lead in a particular area of security that isn't necessarily like the AppSec people's job. They can maybe become your new teammate someday as well. And so if you play your cards right, you're going to have a champion that will not be maybe a 10-time developer, but bring everyone up around them at least 10 times. And that's invaluable. If you're that person in your company, give yourself a pat on the back because you are gold. All right, that is the end of my talk. I want to leave you with some resources. There's some awesome books that I think are really worth checking out. The DevOps Handbook is where a lot of this talk came from. It's a really, really well-written book. Will teach you a lot about DevOps. The Phoenix Project, also a great book for DevOps. Accelerate. My coworker suggested I recommend this one. I personally have not read it, but apparently it's a fantastic DevOps read. The Unicorn Project, and then last but not least, a book by Tanya Jenka, who actually was the original author of this talk. I'm presenting it and giving my own spin, of course, but she actually wrote these slides. She also wrote a book called Alice and Bob Learn Application Security. Fantastic book. You will learn so much about AppSec from it. It's very dense. It's very good. I liked it so much I put it on 2 slides. So more resources is me. You are welcome to email me at any time if you have any questions. There's a cybersecurity community called We Hack Purple that I will give a little bit more details on here in a second. We have a great blog at my company, Bright. It just goes over lots of security issues, and it's geared toward all levels, but especially if you're a beginner in AppSec, it's quite interesting. And then also, We Hack Purple, the community, has a secure coding course, so you can send your people there if they're interested in application security, and it is free now, free 95. So here we go. This is the We Hack Purple community. You can join it. It's free. There's over 6,000 people in it. It's a very active community. All kinds of people from all over cyber. So we have CISOs, we have developers practicing good application security, we have pen testers, we have red teamers, we got blue teamers, we got purple teamers, we got all kinds of people. We got students, we got people who just like AppSec or InfoSec, they like cybersecurity, they don't really work in it. There's all kinds of people. We have tons of events, we have tons of webinars. There's so many classes that you can take there, and it's free. It's a really great resource. Definitely come check us out. You'll see me around there too, so that's kind of cool. Maybe you can be like, just say hi. So, because this is a pre-recorded talk, we don't have any time for questions, but what's going to happen is that if you type your question right now, I believe, in the chat, the event organizers are going to send them to me. And then what I'll do is I'll answer them later on YouTube, and we'll put it on our social media. So you can find me on LinkedIn. You can find Bright on LinkedIn and on Twitter. Just search for Bright App Sec. And also the event coordinators, I believe, will get you those questions via those channels as well. So I'm going to do my best to answer all those questions as best as I can. All right, so what did we learn today? Well, security is now a part of DevOps. DevSecOps. Security is everybody's job. Thank you.
Very much, Akira, for your great talk. And thank you all the participants who joined the talk and spent this weekend on learning something new.